Hi everybody, welcome to video number 27, Decision Tree Classification in ENVI. So recall that we've been working with this Landsat image of Yellowstone. In the previous videos we talked about how classification works, and then we picked a bunch of training polygons, each one that represents a different end-member land surface or an end-member class that we'd like to break the image out into. And in the last video, we actually looked at the spectral separability of those classes and saw that water was really easy to separate, but burned trees and rocks were going to be pretty similar and pretty tough to separate. So in this video, we're going to take the criteria we developed, the spectral separability criteria, and actually include it in a decision tree classifier. So in this video, I'll give you a very quick overview of what a decision tree classifier looks like, and then I'll show you how to do it in ENVI. So here's the basic structure of a decision tree. What you do is you come to an unknown pixel, and the question is, how should I classify this pixel? And you start asking yes or no questions of the pixel. So in this case, the first question is the reflectance in the near infrared less than 10% or greater than 10%? All right, if it's less than 10%, then it's probably water. So that moves you on to the next decision node, which is the reflectance in the green. If it's greater than 30% reflectance in the green, it goes into this arm. If it's less, it goes into this arm. Subsequently, we can ask a bunch of questions about reflectance in the red or reflectance in the shortwave infrared. And if we've come into this arm, we'll actually bring in a digital elevation model, a DEM, and ask, is that pixel less than 800 meters? If so, it's probably an irrigated crop, some farmland. If it's greater than 800 meters up in the mountains, it's probably a tree. So you can see we can bring in lots of different information, and by this cascade of branching yes or no questions, we can actually isolate things into their classes, and each of these kind of dead ends or leaves on the decision tree is actually going to be a class. And importantly, if something ends up in a class early on in the tree, so if a pixel ends up as water, it can no longer be available to be classified as something else later on. So by running this on each pixel, we'll be able to hopefully classify each pixel. So let's go ahead to ENVI, and I'll show you how to do this in ENVI. So just to remind you, we've got our Landsat image of Yellowstone. We made 5 end-member regions of interest that correspond to burned area, trees, rock, water, and meadow. Okay. Then in Excel, we actually looked at the spectra for these 5 end members, and we developed criteria that we can input into our decision tree. And in this example, we're going to use the 4 band ratios. And so recall, the first thing we're going to want to cull out is going to be water. Then we're going to cull out the meadows. Then we're going to break out the burned areas. And finally, we're going to split the remaining pixels into trees and bedrock. So we're going to be coming back to this as we set up our decision tree. So to do a decision tree in ENVI, it's going to be under classification in the toolbox, and under decision tree, and new decision tree. Now, here's our first branch or node in our first 2 leaves or classes. So I'll double click on this node to enter my first expression. And I'm going to bring this back up, and I'm going to get myself in a situation where I can see the decision tree input and I can see my Excel spreadsheet. And my first expression is going to be band 1 over band 7 is greater than, why don't we call it 4.5, something in between water and the next highest ratio of trees. Now importantly, instead of using the greater than sign, something like this that you might be used to, I'm actually using the IDL syntax here, which is GT for greater than. Less than would be LT. And I urge you to look at the help for decision tree, and you can read up on all the possible syntaxes that you can use to write in decision tree criteria. There's a lot of different things you can do, including using AND statements. You can use built-in NDVI ratios, a bunch of things. But the most basic thing we've done here is we have basically, it's always going to be an if statement. If the ratio of band 1 over band 7 is greater than 4.5, if the answer is yes, you go to class 1. If the answer is no, you go to class 0. So I'm going to hit OK. It's then going to prompt me to tell it what band 1 is. So I'll double click that, and I'll locate on my original Landsat stack band 1 here. Hit OK. Notice this thing's going to keep wanting to hide behind your screen, so I'll go find it again, double click band 7, go to my stack, and choose band 7 off my stack. Okay, so that's great. I've got my code in for node 1. Now, keeping in mind, if the result of the first if statement is true or yes, then that is going to be water. So I'm going to double click that and make that water, and I can also assign that a color, probably blue for water. All right. So if the ratio of B1 to B7 is greater than 4.5, it's going to be true, it's going to be water. All right, if it's not greater than 4.5, then it could be any of the other pixel types or any of the other surface types. So what I'm going to do now, this is not going to be a leaf. It's not a dead end. I'm going to right-click, Add Children, and that's going to create another node there for me. I'll double-click the node, call it node 2, and this time I'm going to be using band 3 over band 4, and if that ratio is lower than about 0.5, then I know it's going to be a meadow. So B3 over B4 is less than LT. Oh, let's call it 0.5, I suppose. Then it's going to be a meadow. I'll hit OK. It's going to prompt me now for band 3 and band 4. Get those labeled and identified. All right, so now back to my tree. So if that statement was true, then it's going to be a meadow pixel. So I'm going to go to my dead end here, and I'm going to make it meadow. And actually, I like the color light green for meadow, so that's fine. If that statement wasn't true, then I'm going to need to make one more decision. So this will be my third node. This time we're going to use band 4 over band 6 to discriminate between, to try to isolate the burned pixels away from the trees and the bedrock. So B4 over B6 is less than, oh, this is going to be a close one, so I guess I'll call it 0.25, hoping to isolate those burned pixels, maybe 2.6. Okay, I'll hit OK. I screwed up the syntax. I should have used less than. Okay, it's going to prompt me for band 6. Identify band 6. So if the answer to that was yes, then that was going to be a burned pixel. Just check myself on that. That's correct. It's going to be a burned pixel. I'm going to color that actually red for burned. Okay, and then finally I'm going to make one more decision node here. And this decision is going to come down to band 4, band 5. If the ratio of band 4 over band 5 is less than 0.65, let's say, then it's going to be bedrock. If it's greater than that, it's going to be a tree. So I'm going to hit OK. So if the answer to this statement is yes, then it's going to be bedrock. And for that, I'll assign a color maybe purple. And of course, if it's not bedrock, then there's only one choice left that it can be, and that's trees. For that, I'm going to pick a dark green color. Okay, so I've got my whole cascading decision tree here. All my bands are identified. Oops, I got to get 5 identified there. So get 5. All right, all the bands are identified. I've got my whole structure. I'm going to save this so I can come back to it later if I want to. I'll call it Yellowstone Decision Tree, and that's going to be saved as a text file. And I'll hit OK. Good, so that's saved if I want to use it later. Now I'm going to try to execute it and hope it works out well. So Options, Execute. I'm going to call it DT. I'll just call it Decision Tree. Try that. So it's breaking out the classes. Okay guys, so I'm really not happy with how that worked out. I've got a ton of green in here. That's my meadow. So it looks like that the lake, the water came out okay, and we did get a fair amount of the burned area as well, but everything else went into the meadow category. Really not happy with that. So what I'm going to do is try to go make a change. I'm going to go back to this decision, and I had originally used a cutoff here of less than 0.5. I'm going to change that cutoff to less than 0.32 and try to really tighten up so fewer pixels end up in the meadow category. So I'm going to hit OK. I'm going to save my tree again with the same file name. And then I'm going to change the output parameters. So I'm going to change the file name, call it Decision Tree 1. And as soon as I did that, it started working on it. Well, after about an hour of playing around with that, I'm unable to figure out why all of these pixels were accidentally classified as meadow when many of them should have been classified as trees, many of them should have been classified as bedrock. It appears that there's some software problem with the decision tree in the version of ENVI I'm using. It appears that the decision tree was set up correctly but did not execute correctly, and I don't have time to figure out exactly why. So we're going to have to leave it there. At least you now understand how the decision tree tool works, so you can use it in the future. So as a reminder, in this video, you learned what a decision tree is and how to design a decision tree in ENVI. Join us for the next video where we'll look at a couple of different algorithms for supervised classification, spectral angle classification, and maximum likelihood classification. We'll be doing both of those in ENVI. Thanks for listening. Bye.